Welcome to solverfy.
This is the answer to Chapter 15, problem number 66 from the Smith Organic Chemistry textbook. And this problem is asking us to draw the mechanism by which arachidonic acid is converted into 5-HPETE for the synthesis of a biomolecule, the biosynthesis of a biomolecule. And this is basically just a free radical reaction like we've seen before in this chapter. So the oxygen molecule is going to start by abstracting this proton. I would also note I've drawn the overall reaction up here, and I've drawn out the entire molecules up here at the top. But to save time and space and effort, I've drawn only the part of the molecule that's actually going to participate in this reaction, and I've abbreviated the rest of the molecule with an R. I would always suggest that you guys do this as well. There's not really any point in drawing a whole bunch of carbon chain that's not going to actually participate in the reaction that we're looking at. So just take note of that. This proton here is the one that's going to be abstracted. And so this bond breaks. It's cleaved homolytically. So one electron from the bond goes to form this new goes to form this new oxygen-hydrogen bond. And the other electron from the carbon-hydrogen bond reverts to the carbon to create this free radical. And so we have this free radical here. So the next thing that's going to happen is this double bond is going to transpose, which is always a possibility in an allylic system with a free radical. So that's the second step. The next step is going to be with the free radical up here now, after the double bond is transposed, the free radical and a radical on the oxygen are going to combine to make a new carbon-oxygen bond. So once that happens, the next thing that's going to happen is this second oxygen is going to abstract a proton from another molecule of arachidonic acid. And so again, it's going to be this proton that's most easily abstracted. And so that's what we see here. And then that is going to give us our final product. And also of note, it's going to produce another molecule of arachidonic acid with a proton abstracted and a radical in the allylic position, just as we have here as our first intermediate. And so that's going to be ready to re-enter this cycle and continue this reaction. And so the reaction will be self-sustaining because of that until we run out of arachidonic acid. And that is the answer to Chapter 15, problem number 66.